Hello students. Now we are going to discuss a important topic in organic chemistry, electron migration effects. So these electron migration effects are the very important topics. So first, so what is the meaning of the electron migration effects? So generally we know that the factors that are responsible for the developing the polarity in a given molecule, by which one migration of electrons or displacement of electrons. So condition here, condition, the factors that are the factors that are responsible for developing polarity in a molecule. Polarity in a molecule by displacement or migration of electrons. Migration of electrons are known as electron migration effects. This one, electron migration effects. Now, in this, these electron migration effects also called here electron displacement effect also. Both same only. Electron displacement effect or electron migration effect. All are same. Okay. So in this case, these electron migration effects are classified into two categories. This one classified into two categories. So in these two categories, first one, permanent effect. Another one is temporary effect. Okay, these are the two types. One is a permanent, another one is a temporary. So this permanent effect again classified into three categories. Okay, these are classified into again three categories. One is inductive effect. Next, mesomeric effect. Next, third one is hyperconjugation. Hyperconjugation. Okay, these are the three effects belongs to permanent effect. So the temporary effect is classified into only one category, that is electromeric effect. Electromeric effect. So this one is the classification: inductive, mesomeric, hyperconjugation. These three belongs to permanent. Only electromeric effect belongs to temporary effect. Now we will discuss always the permanent effect of these three: inductive, mesomeric, and hyperconjugation. So now coming to the first one is inductive effect. So what is the meaning of here? Inductive effect. We will discuss very clearly step by step. Inductive effect. So in this inductive effect, so generally, so how to give the statement or define these inductive effect conditions? So generally, if you observe any covalent bond, generally if you observe a covalent bond, covalent bond. So that covalent bond depends on the electronegativity difference. Suppose this one is the one bond. So this bond contains here two different electronegativity atoms. Suppose here less electronegative atom present, here more electronegative atom is present. So that time only inductive effect is possible. Okay. Now I will give the statement about this inductive effect. Then simply the phenomena by which the phenomena by which polarity is produced. Polarity is produced. So which one here producing? In a molecule. In a molecule. Due to electronegativity difference. Due to electronegativity differences between two atoms. Between two atoms. So that process only called inductive effect. Okay, that process is called inductive effect. So in this inductive effect, the other names of this one also important. So generally or casually they will use the other names of this one is called polarization effect or distance effect. Inductive effect is also called polarization effect and inductive effect. Sometimes they will call permanent effect. Why? Because this is an example of permanent effect only. So in this, in inductive effect, it is also another important point. It is operative only on sigma electrons. It is operative only on sigma electrons. Sigma electrons. So that means what? No pi electrons. No pi electrons are involved. This is also important point. Okay, and another one is, so in this case, this is also called, generally we know that displacement of electrons. Okay, so this effect is also called displacement effect. It is also called displacement effect, but not a delocalization effect. Delocalization effect. These points are very, very important. Okay. So sigma electrons only involves in this, and it is displacement effect only, but not the delocalization. So there is no conjugation possible in this inductive effect. That is the meaning. Now, so based on that condition, we will discuss. So inductive effect is classified into two categories. One is plus I effect. Another one is minus I effect. So the plus I effect means it is also called electron releasing groups, and the minus I effect is called electron withdrawing group. Okay, electron releasing is plus I, electron withdrawing group is minus I. Then we will discuss that plus I and minus I group alone. First one, plus I effect. So plus I means the group which is release electron more than carbon and hydrogen in a chain. More than carbon and hydrogen in a chain is called plus I effect. So in this plus I effect, the order also very important. If you know this order, you can solve the problems very easily. So based on the releasing character or releasing capacity, then the order is first NH minus is more effectively release the electrons. Next Nr minus, this one also release the electrons. O minus, next O minus is effectively release electrons, then COO minus, then it is R group. So what is the meaning of R? Alkyl groups. Now these alkyl groups alone we will discuss. CH3 C bond CH3 bond CH3. It is attached to the chain. This group is called tertiary group. It is more effectively release the electrons than CH bond CH3 bond. So it is a secondary carbon. Here this is bond attached to which one? Chain only. Here also this one attached to chain. Next CH3 CH2. This is a bond. Means it is a primary. So primary carbon. This primary carbon attached to the main chain. Then after that, this one CT3 group is more releasing than CD3. CD3 more release than CH3. Then after that CH3, tritium, next deuterium, least one is the hydrogen. So hydrogen atom is compared to all other compounds, it is always neutral. It is always neutral only. So this is the plus I group order or electron releasing group in inductive effect. So you have to memorize this order also based on this condition. It is effectively release the electrons NH minus, after that Nr minus. Next O minus release electrons, COO minus, carboxylate ion. Next alkyl groups. These are the alkyl groups. Here what it explain in T means. T means tritium, isotope of the hydrogen. D also isotope of the hydrogen atom. It is a tritium, this one is deuterium. So these two are the isotopes of the hydrogen. Isotopes. Isotopes of hydrogen. Okay, one is a tritium, another one is deuterium. Now, another one is minus I effect. This order also I will give you now. Minus I effect. So generally, so what is the meaning of here minus I effect? The group which is withdraws electrons more than carbon and hydrogen in a given chain is called minus I effect. Okay, is called minus I effect, or it is also called electron withdrawing group. So before case it is called electron releasing group. These groups are now called electron withdrawing groups. So what are the examples belongs to? So these electron withdrawing groups we will discuss that order. Order. Example. First one. OR2 plus it is oxygen has positive charge means more effectively withdraws electrons only. Next OH2 plus here R group given, here H group given. So in this effectively it is withdraws electrons from the carbon chain. Then next NF3 plus. Next Nr3 plus. The positive charge on these all groups effectively withdraws the electrons. The next after that SR2 plus. This group also effectively withdraws electrons. Next NH3 plus. So these groups alone withdraws electrons from the carbon chain. Next, after the NH3 plus ion, so it is very important only. This group is CX3 group. So what are the CX3 groups present in this? That examples CF3 it is greater than CCl3 it is greater than CBr3 it is greater than CI3. So these are the groups CX3 means. So these groups alone here CX3. Now after CX3 group, mostly they will give NO2 nitrogen dioxide. This group also effectively withdraws electrons. Next further after the NO2 group, cyanide. Next already we know that this group is a sulfate SO3H. After cyanide, SO3H group is effectively withdraws electrons. Next, this group is the aldehyde group. Next, C double bond O, R represents it is a ketone, aldehyde ketone group. Then after that, CO, OH, carboxylic acid group. Next, CO, Cl, acid halide functional group. Next, CO, OR ester. Next, CO, NH2, amide is the functional group. So after that, these all acid derivatives before carbonyl compounds. After that, acid derivatives. Next, halogen family will come. So that is X only, halogen family. So in this halogen family, that example, first fluorine, next to chlorine, bromine, iodine. So these are the fluorine, chlorine, bromine, iodine order for the next. So after completion of this one, alcohol group OH. Next OR, all carboxy groups, methoxy, ethoxy, propoxy, isopropoxy. So like these groups are all under in this OR group only will come after OH. Then next another one is NH2 group. If NH2 group is attached here, this one also acts as a minus I. Means these are all are the electron withdrawing groups only. Then after the NH2 group, C triple bond CH. Then after the CH3 C triple bond CH, we can write that C6H5. C6H5 it is a, will write clearly C6H5 or it is phenyl part only. After that, phenyl or C6H5, CH double bond CH2 alkene. So again least one is the hydrogen. So again least one is the hydrogen means it is always already told neutral compared to all other groups. So hydrogen is always a neutral atom. So neither lose nor gains the electrons. Okay, these are the order of the plus I and minus I groups. Plus I and minus I groups. In this plus I and minus I groups, we will discuss the applications next. So what are the applications here influence the carbon chain? So first, next write the applications in this. First application is it explains stability of carbocations. Stability of carbocations. Second one, it explains stability of carbanion. Carbocations means C plus, carbanion means C minus. Next, third one, it explains stability of free radicals. Carbon free radicals. Next, another one, it explains reactivity of alkyl halides. Alkyl halide means Rx is the formula. Next, another one. It explains the acidity of. It explains acidity of aliphatic alcohols and carboxylic acids. Next, it explains basicity of aliphatic amines. Aliphatic amines. And next one, it explains bond lengths and dipole moment of your molecules. So these all are the applications of the which one? Inductive effect. Okay, applications of inductive effect. So on the basis of these all conditions, I will give the formulas about this. Formulas. First, stability of carbocation or carbon free radical. So these two directly relation with the plus I group, inversely relation with the minus I, which is the one formula. How to memorize this? Stability of carbocation or carbon free radical. If any one given, it's directly relation with the plus I group, it is minus I group. So plus I group is nothing but here electron releasing. Here minus I means electron withdrawing group. Next, another one formula. Stability of carbon ion. So it is directly relation with the minus I, inverse relation with plus I. So minus I means it is electron withdrawing group, plus I means electron releasing group. So carbon ion stability increased by minus I, carbon ion stability decreased by plus I. So these are the another formulas. Next, acidity of aliphatic alcohols or carboxylic acids, RCOOH. For the alcohols and carboxylic acids, minus I group increases the acidity. Directly relation with it increases the acidic strength. What about the plus I? It decreases. Now I'm writing here. It is increases acidic strength. Here it is decreases acidic strength. Okay. Next, another formula. Basicity of amines are NH2. For this basicity, always it depends on the lone pair of electrons. Basicity always depends on, basicity means here lone pairs. The group which is release the lone pair of electrons are charged. Here acidity indicates here H plus ions, releasing of H plus ions. Now this RNH2 is directly relation with the plus I, inversely relation with the minus I. So that means here if a plus I group increases the basicity, minus I decreases the basicity. So these are the formulas, very important. So if you memorize these formulas, you can easily identify the given molecule stability of carbocation, either carbocation or free radical or carbon ion, or acidity of alcohols and carboxylic acids. Another one is basicity. So these are very important. The next another one is here alkyl halide reactivity. Reactivity. So alkyl halide reactivity or X. So generally tertiary is always more reactive than secondary. It is more reactive than primary. So tertiary, secondary, primary, this is the reactivity order. Reactivity order. The stability order for this, it is primary is always greater than secondary, secondary is always greater than the tertiary. So that means the stability and reactivity always inversely relation. Stability is inverse relation with the reactivity. Reactivity. This formula also important. Now, if you know these all formulas, you will get easily the inductive effect conditions also. In next video, we will discuss the more number of examples on the inductive effect. Okay, thank you.